We're now going to look at matrix multiplication. This is quite a challenging section, and so make sure you look at this video perhaps a couple of times so that you can see the pattern of how we multiply one complete matrix by another. It's really important to remember when we multiply matrices, we multiply every element of every row by each corresponding element of every column and sum the multiplications. That sounds like a lot to do. I think it would be easier if I actually show you how you do this by an example. So multiplying the matrices. So we've got a order of matrices here where we've got 2 rows and 2 columns. So it's a 2 by 2. We've also got a matrix which is a 2 row by 1 column. For matrix multiplication to be possible, the number of columns of the first matrix, in our case 2, must match the number of rows of the second matrix. So these two things must be equal, otherwise we won't be able to multiply them. So make sure that that happens in the first instance. Alright, so the first row is multiplied by the first column when we multiply matrices. So what does that actually look like? Here's our first row, so it's going to be 4 times 2, and then we go across the row and down the column, and we add these things together. So it's 4 times 2 plus 1 times 9, and we come up with our number being 17. The second row is multiplied by the second column. So here's our second row, so it's going to be 5 times 2 plus 3 times 9. So you do them in that order. And if we add them together, it equals 31. So that might make it a little bit more sense by this statement. We multiply every element of every row by each corresponding element of every column and sum the multiplications. So following through steps 1, 2, 3 and 4. What you'll notice is that the final answer that you have is 2 rows and 1 column. And if we look back to our original orders that we worked out, these 2 outside ones gives us the answer of our order of our resulting matrix. Let's have a look when we have an example where instead of having just 1 column, we've now got 2 columns that we must multiply. So we'll go through these steps again quite slowly. So it's going to be the first row, 1 times 3 plus, we'll move along our row and we go down the column that we're doing, 9 times 2, and we add them together. Then we've got to do exactly that same steps, but this time we do it with the second column. Let me pick another pen so that might become a little clearer. So now it's going to be 1 times 5, 5 plus 9 times 4. So we've done that first row. There's a lot of steps in it, and we've got to remember that we add those together for each time. Let's pick another colour. And we're now up to the second row. It becomes 7 times 3 plus 6 times 2. And then our very last element, we do exactly the same thing with this row, but now we've got our second column. So it becomes 7 times 5 plus 6 times 4. So there's a fair bit of things we must multiply and then add together. And so let's just go through that again, just in terms of steps. Row, across the row and down the column. And then you do it for all those steps. What we had here was 2 by 2 matrix, and then we multiplied it by another 2 by 2 matrix. So if you recall back into our last problem, the column of the first one must be the same as the row of the second one, and then your resulting matrix at the end is going to be these outside two. So it should be a 2 by 2, which is what we've actually got as our answer there. So if we were to add 1 times 3 plus 9 by 2, so 3 plus 18 gives us 21. 1 times 5 plus 9 times 4 gives us 41. Remember, your brackets come before you add them together. Okay, if you need to put those in, make sure that you do. Let's do this example that we have. Okay, so we're going to I'm going to use the same pen colour this time. So it's going to be 2 times 1 plus, don't forget that, 6 times 2. Then leave a gap so you know that you're not including that in that problem. Then we're going to do that same row with the next column. So it's going to be 2 times 4 plus 6 times 5. And I will change colour here with our second row, exactly the same thing. 3 times 1 plus 5 times 2. And now we're going to do exactly the same thing with the second column. 3 times 4 plus 5 by 5. And so we end up with our final matrix. We add this together. 2 times 1 is 2, plus 6 times 2 is 12. So 12 plus 2 is 14. Then we do the next one, remembering your brackets before you add them together. So 8 plus 30 makes 38. And then 3 times 1 plus 5 times 2 makes 13. And then 3 by 4 plus 5 by 5 makes 37. And again, you can see we had a 2 by 2 with a 2 by 2. Our resulting matrix is a 2 by 2. This is a really good table to refer back to if you get stuck with your 2x2 matrix multiplication. So this is just a general formula when we're multiplying them. So it becomes A times E plus B times G, and then so on, just like I've shown you, so that you can use that if you're having problems. For matrix A and matrix B, A and B can only be found if the number of columns in matrix A is the same as the number of columns in matrix B. So that's really important. The last thing is, if we have a look at this general rule, the resulting matrix will have the same number of rows as A and the same number of columns as B. So I've already done that. We have our 2x2 and our 2x2 example that we've just done. We know columns in A must match the columns in B, and our answer will have the order of what is written on the outside, and we knew that was a 2x2 matrix. Caution, matrix multiplication does not work in reverse ways. Okay, so this is the rule that we must remember. Okay, A times B does not work with B times A necessarily. For example, obviously here they're 2x2 and 2x2. It will work because they're exactly the same exactly the same rows and columns. But if we go back to this problem that we had here, where we had a 2x2 and a 2x1, so let's do that. 2x2 with a 2x1. Okay, that may not necessarily work. Okay. So for example, with that one it did work because we had our columns and our rows matching, and then we got our resulting matrix. But if I had done it the other way, 2x1 by 2x2, okay, the rule means that these two have to be the same, okay, but they're not in this situation. So that will not work. All right, your turn to have a go now. Okay, your turn to have a go now. On page 34, I want you to do question 26, 27, and 28. 26, 27, 28. Have fun.